Hello, Algebra 1 students. In this lesson, we're going to learn how to solve a quadratic equation. But before we begin, it's important to define what a quadratic equation is. So what exactly is a quadratic function? It's a function with a degree equal to 2. What that means is that the function's variable will have a squared on it and that there will be no other higher exponents in the function. Let's look at some examples and non-examples of quadratics. In function f, this is a quadratic function. It has a squared, and there are no other higher exponents in the function. Function g is not a quadratic function because the variable does not have a squared. Function h is also not a quadratic function. I do see a squared on the variable, but there is a higher exponent in the function. That means this is not quadratic. And finally, function j is a quadratic function. It has a squared on the variable, and there are no other exponents that are higher than a 2. It's also important to note that a quadratics function makes this U-shaped graph called a parabola. Parabolas can open up, like this one and this one over here, or they can open down. These parabolas are perfectly symmetrical, where this bottom point or the top point are sort of the boundaries of symmetry. Because of that symmetry, most quadratic functions will have two solutions wherever they cross the x-axis. Now I say most because there are some rare cases where that doesn't happen. For example, in this one, it's only crossing the x-axis once because that symmetry point is on the x-axis. And this one is not crossing the x-axis at all. These are very rare, and we will talk about those in later lessons. But the main thing is to remember that most quadratic functions will have two solutions, one on each side of the parabola. Now that you know what a quadratic function is, let's look at how to find solutions for quadratic functions. There are many ways to solve, but today we're going to look at only quadratic equations that have squareds and constants, no x terms. The first thing to do will be to isolate the x squared, just like you would if you were solving a linear equation. So in my example, I started by subtracting 8 from both sides. That gave me 2x squared equal to 50. That I divided by 2, and x squared equals 25. Once you've isolated the x squared, you should go ahead and square root both sides of the equation to cancel out the squared. If I square root x squared, I'll just have x. And if I square root 25, the answer is 5. But wait a minute, we just said that most quadratics have two answers. Where's the second answer? If you think about it, x squared equal 25 means that x could be 5. 5 times 5 is 25. But so is negative 5. Negative 5 times negative 5 is equal to a positive 25. Therefore, this quadratic would have a solution of positive 5 and negative 5. Let's look at one more example. I'm going to start this example by solving for the x squared just like I would a linear. I added 12 to both sides and then divided both sides by 1/2. I came up with x squared equal to 4. My second step then is to square root both sides. The square root of x squared is x, and the square root of 4 is 2, because 2 times 2 equals 4. But don't forget the second solution, because most quadratics have two solutions. Negative 2 is also a solution because negative 2 times negative 2 is positive 4. So let's do a quick recap of what you should have learned today. Today we learned what makes a function a quadratic. We learned the shape that a quadratic graph makes. We learned how many solutions most quadratic equations have. And we learned how to find answers to a quadratic equation using the square root method. If any of these points are confusing or you feel the need to review, please re-watch this video. Have a great day.